So I'm writing the purpose of this session, the next 10 minutes, how to check the unit root in the financial time series. Okay. So the process I am showing you in Eviews. So this is the purpose. So let's move. Suppose I want to check the unit root of any variable like China. So we are having the Chinese index, and we want to know whether this series is a random walk or not. So first of all, I want to plot it graph, and if you see this graph, we are very clear that this series is a random walk, because it is the mean is not constant, the variance is not constant. Okay. The second thing which I want to see is the correlogram. The correlogram. So what is the correlogram? Let me explain. This chart is known as correlogram chart, and here in this correlogram chart, this is the autocorrelation, this is the partial correlation, and this is the value of autocorrelation, this is the value of partial autocorrelation, and it is Q statistic and the probability. So what is this autocorrelation, partial autocorrelation? I am explaining you. So as I said earlier also, suppose I have the series, let me explain the concept first. If you have the series called YT, and YT minus 1, YT minus 2, YT minus 3. So this is a series. You can write it Y at lag 1, which start from YT minus 1, YT minus 2, YT minus 3, YT minus 4, and so on. Now this is the Y at lag 2. So it starts from Y at lag 2. This is the series Y at lag 2. Similarly, if I write Y at lag 3, so Y at lag 3, all these series are coming from the same series, Y at T minus 6. If you find out the correlation of this and this, the value is this. If you find out the correlation of first series and the third series, if you calculate the correlation between first series and the third series, the value is this. If you calculate the correlation between first series and the fourth series, the value is this. So therefore, this part, the first graph, is known as autocorrelation. The correlation of first series with its lagged series, lag 1, lag 2, lag 3, up to lag 36. So I hope you understand what is the meaning of autocorrelation. First graph. Now the problem is in this graph, the first graph, is that it is significant up to many lags. You can see that it is significant up to many lags. It is significant up to many lags. Why it is so? The answer is very simple. If today is correlated with yesterday, and yesterday is correlated with day before yesterday, so it is obvious that today is correlated with day before yesterday. If today is correlated with yesterday, yesterday is also correlated with day before yesterday. So today is also correlated with day before yesterday. Similarly, it extends to up to many level. So the question is that, how to find out what is the actual correlation between today and day before yesterday? So how to find out the actual correlation between today and day before yesterday? The answer is very simple. Control intermediate lags, right? You can find out the correlation between this and this after controlling this. So when you control the intermediate lags, this is known as partial correlation. Similarly, if I want to find out the correlation between YT and Y3, so I have to control two lag in between. The correlation between Y Y3 is find out only after controlling the intermediary lags. So this controlling part you can see here, right? So after controlling, you can see that all correlations are insignificant. Only the correlation 1 is found to be significant, right? So the rule, what is the rule? Now what is the rule? The rule is that when partial autocorrelation is close to 1 at lag 1, this part, when partial autocorrelation is equal to 1 at lag 1, then series is a random walk. Then series is a random walk, because this part is actually the beta. So that when then this beta is equal to 1, the series is said to have unit root problem. The series is said to have the unit root problem, right? This method is known as correlogram method of examining whether the series is stationary or not. Now but these two tests are not very powerful tests, so we are going to very powerful test that is called ADF test. Now let me check you how to do the ADF test. Again, go to view. Now we are having an option called unit root test. We are having an option called unit root test, and we are having different tests here. You can see the augmented Dickey-Fuller test, Philip-Perron, KPSS, ER, SP, and NG Perron. The most popular test reported in the research papers is augmented Dickey-Fuller test, and I want to apply augmented Dickey-Fuller test with level. Level means original values. Intercept, these are the three assumptions. So we can click on the assumption number 3. This is the most important assumption, because after this assumption, the model will capture the trend as well as intercept. Okay, after that, how many lag we should take? The lag we can decide on the basis of some criteria. These are the different criteria on which, with the help of these criteria, we can identify the lags. So the most popular is Squad's information criteria, because it is giving you the lowest number of lags. Then go to OK. Now this is the result of augmented Dickey-Fuller test. Now how to study this augmented Dickey-Fuller test? Let me show you what is the meaning of it. So first of all, what we are doing, we are examining the unit root test. Results of unit root test. So what is the null hypothesis of unit root test? The series is non-stationary or random walk or having unit root. So this is the null hypothesis. Now probability value. This probability value is greater than 0.05, which means null hypothesis accepted, right? Null hypothesis accepted, or it cannot be rejected. So what is the conclusion? What is the conclusion? That series is a random walk. Series is a random walk. Okay. So in Eviews, we can run the unit root test in hardly a few minutes. But what is the meaning of different options? You may not have clarity on that. So now I am going to explain what is the meaning of different options. So let me explain you that also. Basically, if you remember, I explained that yt equal to beta yt minus 1 plus et. This, in this equation, if beta is equal to 1, then the series is suffering from unit root problem. So now I am doing one small change here. I am subtracting this equation by yt minus 1 equal to beta. So I am subtracting yt minus 1 from both the sides. So you can see that I am subtracting yt minus from both the sides. This value is called, now yt means value of y today, value of y yesterday. So if you take the difference, so this is known as change in y, change in yt. Similarly, in this case, you can take yt minus 1 constant common, yt minus 1 we can take it common, plus et, and I just replace this value by rho yt minus 1 plus et. You cannot believe that this equation is known as Dickey-Fuller test. This equation is known as Dickey-Fuller test, and Dickey-Fuller was famous by after giving this equation, and initially he gave this equation where the null hypothesis is that this rho is equal to 0, because whenever rho equal to 0, beta is equal to 1. So when you apply the regression between delta t as dependent variable and yt minus 1 as an independent variable, and rho is found to be insignificant, it means your series is having the random walk. So this is the concept behind the unit root and unit root testing. But the problem is that later on it is found that this equation is suffering from very basic problem, that this equation have also very low Darwin-Watson values. Now, so many people who were not like the Dickey-Fuller, they were start criticizing that this equation is not a complete equation. This is not the right equation. So this equation cannot be used for testing unit root. So then Dickey-Fuller make a small change in the equation and modify this equation to a modified one. So now I am telling you the modified equation. So after that you will understand that how to use this equation. So now let me explain the modified equation. Don't worry, this is not very difficult, but it will explain you with clarity that why to use this. Okay, so I am starting from here, because this is the equation given by the Dickey-Fuller, and later on he modified the equation, like he said that now I am giving you a new equation, that delta yt, this is the change in y, equal to alpha plus beta into time plus rho into yt minus 1 plus let's say gamma 1, gamma I, and yt minus 2, gamma 2, gamma 1, gamma 2, and so on. Okay, if you understand this equation, everything will be very, very clear. So in this equation, there are three assumptions. This assumption is known as intercept. This assumption is known as trend. And this assumption is known as unit root, right? And these assumptions are the lagged values. Lagged values. So whenever you run the unit root, you can say here, software is asking for intercept, trend and intercept, and none. So if you click on none, it means you are coming back to the Dickey-Fuller. You are not applying the augmented Dickey-Fuller. If you click on intercept, it means you are allowing only intercept. You are not allowing the trend. If you click on the trend and intercept, it means you are applying the full equation of Dickey-Fuller. So that's why I recommended you that whenever you apply the unit root test, click on trend and intercept, because we have to allow intercept and the trend in the equation, because only after that you are going to apply ADF test. Similarly, this row is the null hypothesis of the ADF test, and this lagged value, how many lagged values we can consider, this is decided by Squart's information criteria and maximum up to 24. But here you can see in this portion, okay, if you click on this, here you can see in the option that 4 lag are considered by the software for this part. So I hope you understand clearly the meaning of unit root test now. Because if you understand this equation, uh, the clarity on unit root test will definitely come. Okay. So this is the concept of unit root and how to test in Eviews. We can also see. I am showing you one more example. After that, it will be very clear that how to check it once more. So let me click on this and will show you now on Japanese market. This is the value of Japanese stock indices. I click on the view unit root test, and the software is asking me which test you want to apply. I default Dickey Fuller test. I go with trend and intercept. I click on the OK, and now this is the result. My probability value is greater than 0.05. So it means this series is suffering from the unit root problem. So it means I cannot use this series for any kind of modeling, right? I cannot use this series for any type of modeling. So this is the concept called unit root concept. And I hope you understand now what is the concept of unit root. And so this is the unit root concept. And